Welcome to Theory of Computation class. Here I am going to give an introduction about encoding of Turing machine. So in previous lecture I gave an introduction about undecidability. So there are three type of problems are available: solvable problems, unsolvable problems, and partially solvable problems. Solvable problems languages are considered as recursive language LR. Undecidable problems category languages are LNRE. Partially solvable problems category languages are called as LRE. So if you want to implement an undecidable problem solution, first we should go for encoding. So the meaning of encoding means all type of, that means a set of states and input tape symbols, replacement symbols. So these are all available in a Turing machine. So those values should be written in a binary format. So that is the meaning of encoding. So if you want to assign an integer value for a given binary string, then that notation is called as encoding of Turing machine, which means that we should assign 0 and 1 for an input alphabet symbol sigma. So if you consider a Turing machine M, so already Turing machine is a 7-tuple representation which contains Q, sigma, tau, tilde, initial state, then blank space symbol, final state. So these are all the 7 categories are available. And we should write the set of states Q. So for here in this example, Q contains Q1, Q2, Qn values. So instead of the original symbol, we should write its corresponding binary value. That means we should only represent zeros. So if our initial state is Q1, we should represent only 10 for Q1. If any Q2 symbol is available, instead of finding Q2, we should replace it as 00. That means 0 power 2. Instead of Q3, we represent the symbol as 0 cube. Like that, n number of states will be represented from 0 power 1 to 0 power n. The same symbol should be noted for input values. It means sigma. So here sigma contains 0, 1 and the tape contains blank symbols in it. So if any 0 is available, we should represent only 1, 0. Instead of 1, it is a second symbol, so we should represent 00. If you consider blank space as the third alphabet symbol, we should write 3 zeros for it. The same thing for directions. There are two directions are available. One is left direction and another one is right direction. Left direction is represented with single 0. Right direction should be represented with 00. And if you take the notation, that means transition function, tilde, that means Turing machine input contains 2 parameters and the output is 3 parameters. The parameters are set of states and the input symbol on tape. This is the input and the output is the corresponding state, then the replacement symbol with the direction. So it is represented as I, J, K, L, M. In these 5 values, I and K represents set of states. So your I value will be starting from 1 to N. And J and L are input tape symbols. M is the direction. The maximum directions are 2. So the M value should be less than or equal to 2. So this is one notation. This is for a single transition function. So if you consider Turing machine, there are many transition functions are available. We should note that encoding format as M1, M2, M3 like that. So the corresponding encoding format is, so if you consider this tilde of Qi, Xj equal to Qk, Xl and Dm, it should be written in an encoded form. So the encoded form is namely M suffix I. So here I means either it represents the first transition function or second transition function like that. So if a Turing machine contains 4 transition functions, then 4 encoded forms should be written. M1, M2, M3, M4 like that. And the encoding format contains ones. So it's starting with double one and it should be ending with double one. Intermediate values are 0 power I, double one, 0 power j, double one, 0 power k, double one, 0 power l, double one, 0 power m, where this I, j, k, l, m are subsequently written from this input and output values of that given transition function. So like that, for every transition function, we should write an encoding form, and the final encoding form capital M is equal to, this is final encoding form. So these are all the 4 different transition functions encoding value that should be embedded within 111. Okay, so let us go to the problem. Here they will ask a question as construct coding for a given Turing machine. So they will give the 7-tuple representation. So here if you consider a Turing machine, the Turing machine name is M with the input symbol is 011. So if you want to construct an encoding, the input string is not necessary. So you can ignore the second parameter. So if you consider M, so these are all set of states. So you write this as set of states. This is the first parameter and the second parameter is sigma, and the transition functions here 4 transition functions are given. So I put the number for these 4 transition functions. So you can able to write 4 encoding format for these functions, and the initial state is Q1, final state is Q2. So first step is, this is the step 1 notation. So in step 1, you should write the set of states here. The first parameter contains Q1, Q2, Q3. I want to write an encoding form. So instead of the Q1, Q2, Q3 symbol, I only write the number of zeros. So this is the first state. So only 1 0 should be written. So 0 power 1. And Q2 means 0 power 2, Q3 means 0 power 3. And if you consider the second parameter of Turing machine, it contains 3 symbols, 0, 1 blank space. So instead of it, we should write it as 0 power 1, 0 power 2, 0 power 3. And there are 2 different functions or directions are available. So namely left and right direction, which should be written as 0 power 1, 0 power 2. So we should write these Q, sigma, D parameters for any Turing machine notations. Then we should take the encoding form. So the first encoding form is tilde of Q11 equal to Q30R. So I put the symbol as I, J, K, L, M. So the generalized encoding format is Mi is equal to 0 power I double 1, 0 power j double 1, 0 power k double 1, 0 power l double 1, 0 power m. So this is the generalized form. So I write it in this notation. Here the first parameter is Q1. So you should go to step 1. Q1 means you should write only 1 0. So I write only 1 0 here. Then what is your j value? It is 1. So just search it in step 1. 1 contains 0 power 2. So you should write 0 power 2. For differentiating I and j value, the intermediate 2 1 should be written. The same thing for k. So consider k, it is Q3. You go to check it out in step 1. Q3 means 000. So I write 000. For differentiating jth 0 value and kth 0 value, I put double 1. Then L value is 0, which means single 0. For differentiating kth zeros and lth zeros, I write double 1. And then R means double 0. That will be deferred with double 1. So this is the generalized form. So just check here, it is 0 power I double 1, 0 power j double 1, 0 power k double 1, 0 power l double 1, 0 power m. Like that, I want to take the second transition function, that means tilde of Q30 equal to Q1 1R. So same thing, it is I, J, K, L, M. Generalized notation is 0 power I, double 1, 0 power J, double 1, 0 power K, double 1, 0 power L, double 1, 0 power M. Then this I, J, K, L, M zeros are referred from step 1. So like that, I write the encoding format for all these transition functions, which are namely M1, M2, M3, M4. So these are all comes under step 2. And step 3 is the final encoding format. The final encoding format is capital M is equal to, it should start with 111 and it should end with 111. And the intermediate notations are M1, M2, M3, M4. These values will be deferred with 11. So the intermediate values are 11. So I write that generalized notation here. So there are 4 functions are available. These M1, M2, M3 values are already written. I only put the specification of that symbol only in the final encoding format. So in this way, we can able to find the encoding of a given Turing machine. So this is the second problem. So here totally 5 different functions are given. So this is capital Q. Sigma contains 3 symbols and Q1 is the starting state, Q5 is the final state. There are 8 different functions are given. So I only write Q here with 0 power 1. Either you can write it as power or you can write continuous values. And sigma contains 3 values, 0, 1 blank space. So I put the symbols here and the directions are 2 directions that will be specified with 00 or single 0. Then the generalized format is 0 power I, double 1, 0 power J, double 1, 0 power K, double 1, 0 power L, double 1, 0 power M. So you consider first one. So first one, this is I, it is J and the output values are K, L, M. These values should be checked in step 1. So this is step 1. So Q1 value is single 0, then double 1. 0 means single 0, double 1. Q2 means 2 zeros, double 1. L means single 0, double 1. M means R, which contains double 0. So this is M1. For M2, Q2 means double 0, double 1. 0 means single 0, double 1. Q3 means triple 0, double 1. Then L means single 0, double 1. R means double 0. Like that, we should write the encoding format for all these 8 transition functions. This is step 2. So you write the answers for the remaining notations. Then the final encoding format is capital M is equal to 111 followed by M1 to M8 values. Each value should be deferred with double 1. And then the last value should be 111. So this is the notation. So the question will be asked as find a code or write an encoding format for given Turing machine. So if the question is asked as coding or encoding word in it, then we should follow this format. Thank you.